Hey folks, thanks for watching. We're going to do solution stoichiometry practice. We're going to go to the back of the worksheet. Okay, it says number 3, it goes 3A, B, C, CI, and CII. So they're all related. Okay, sulfuric acid, there's no hydro, so that means I have to have a oxygen in here. And it tells me in the prompt what the molarity is. Ammonia, oh, that's a weak one, all right? So it's not a regular double replacement. And they give me the equation, and they give me the molarity, and they give me the equation, okay? So let's write sulfuric acid. All acids start with an H. It's sulfuric, so that means it used to be sulfate. So that's SO4 minus 2. So it's H2. Let's fix that. H2SO4 aqueous, okay, with ammonia, NH3 aqueous. Okay, so now let's look at this because it tells me what the products are. The product of this reaction is aqueous ammonia sulfate. Oh, let's wait a second. Let's go backwards, right? Well, let's write that. So that's NH4 2SO4. And that's aqueous. Okay? Well, I know that aqueous ionic compounds dissociate 100%. So I am going to get 2 NH4 plus 1 aqueuses plus SO4 minus 2 aqueous. Okay? So we gave you the reaction on that one. So take a minute and go back and read what it says. Okay? They want us to calculate the milliliters of acid to neutralize 12 milliliters. So we folks are going milliliters to milliliters. Okay? So this is a nice long one. So I've got 12.0 milliliters of NH3. Well, how much sulfuric acid do I need? Right, so here's my recipe. Guess what I didn't do? That's why my answers were wrong on the dry erase board up front. I didn't balance. I need 2 ammonias, okay? So make sure you got that balanced in there. Okay, so let's think back to our mole. Milliliters to liters to moles of my other chemical to liters to milliliters. Whew. Yes, folks, that's the longest one you've had to do. Okay, so now what we're going to do, we're going to take these words diagonal. We're going to do all the diagonal words. Notice I am not putting any numbers. You can think where the numbers come from, but be careful because you've got each set of words showing up twice. That's where some of you guys are getting stuck, especially that molarity. That molarity is hurting you guys. Okay, so milliliters and liters, that one's 1,000. Okay, moles and liters, this is molarity. Now I've got to make sure that I'm using the correct molarity. This is NH3, so this is going to be 0.0859 moles for 1 liter. Moles to moles, that's my reaction. Okay, so I'm going to see a 2 in front of ammonia, a 1 in front of sulfuric acid. Moles again. Well, this is molarity, and I've got to make sure it's molarity of sulfuric acid. So that's this one. So this is 0.171 and 1 liter. Okay? And I remember that 1,000 milliliters is 1 liter. Okay, calculator nightmare kind of here, folks. I've got 3 numbers in the denominator. I need to use parentheses, or take the numbers at the top, hit equals, divide by everything in parentheses, and you should end up with 3.02 milliliters. Okay? All right. So that's how much in a perfect world, if I use 12.0 milliliters of ammonia, that's how much sulfuric acid I should need. Well, in question C, limiting reactant. Yep, I gotta go back to that in stoichiometry. A lot of you guys got stuck. If I start with 100 milliliters of ammonia and 50 milliliters of sulfuric acid, who's going to make the smallest amount of product? Okay, so I'm going to need two factor label charts. I'm going to need 100 milliliters of ammonia, and I'm going to go to moles of product. Okay, so I'm going to go to moles of NH4 plus 1. Both times I have to do the same chemical. You could have gone to the sulfate, totally fine on that, okay, but it's going to go do the same thing, right? I need to compare the same thing. If I don't go to the same thing, then I can't compare. All right, so milliliters, then I'm going to go to liters of ammonia, then I'm going to go to moles of ammonia, then I'm going to go to moles of ammonium, pardon me, NH4 plus 1. Okay, that's what my map said. I followed the words. Now I'm going to go down below. Okay, milliliters and liters. 1 liter is 1,000 milliliters. Moles and liters is molarity. Make sure I go back to the molarity of ammonia. 1 liter, 0.0859. Moles to moles, that's the reaction. That's 2 to 2. Okay? So when I do that one, okay, I get 4.30 times 10 to the negative third moles. Okay, careful your calculator, you got two numbers on the denominator. We're going to do the same exact thing, but the chemicals are going to be a little different. Liters of H2SO4, moles of H2SO4, moles of, oops, sorry there folks, it's going to make, wait a second. Oh, I gotta check my calculator there. I might have a problem. Okay, I'll check that in a second. Moles of NH4 plus 1. Okay, I'm gonna take this, I'm gonna go diagonal. Okay, liters and milliliters. 1 liter is 1,000 milliliters. Moles to liters is molarity, but I've got to make sure I take the sulfuric acid one. 1 liter is 0.171, and moles to moles is from the reaction. So sulfuric acid is a 1, and ammonium is a 2. Okay, let me check with my calculator here. Oops, I think this is 8.59 times 10 to the third. I'm going to check that again in a second. Okay, let's try the other one. 50 divided by 1,000 times 0.171 times 2. 1.71 times 10 to the negative 2. Okay, so what I'm going to look at here, which number is smaller? Okay, so I've got 10 to 8.59 times 10 to the negative third, or I've got 1.171 0.71 times 10 to the negative 2. Now I've got to think, like, wait a second. Right, in your head, write it as normal notation, okay? This number is smaller, okay? So I'm going to make a smaller amount. So therefore, NH3 is the limiting reactant. NH3 made the smallest amount of product. So NH3 is the limiting reactant, and he made 8.59 times 10 to the 3 moles of product. Here, if I used all my sulfuric acid, I could make 1.71 times 10 to the negative 2 moles of ammonia. Okay? So, what do I have left? That means I have to have excess H2SO4, so that is going to be an acidic solution. Okay? Hope that helped. Go back to your stoichiometry notes and remember limiting reactants.